Let's look at a couple of examples for solving systems using the addition-elimination method, where we have to modify one or both of the equations in the system. So let's get a system down that we can work with. For example, I want to look at the system 3x plus 6y equals negative 6 and 5x minus 2y equals 14. Now when I look at this, there is no equation that is already the exact opposite, and there's none where I can just subtract to make that so. So what I need to do is I need to change one of my equations to be able to add these two together. And it really doesn't matter if you choose to eliminate the x or the y. The difficulty will be when you choose that, how much work is going to be needed. If I wanted to eliminate my x's, I would have to multiply both equations by something that would make 3 and 5 a common multiple. So I have to think about multiples of 3 and 5 and what I would need to do to both equations to make those exact opposites of each other. And that's going to take me more work than if I do that to the y, because already they have the opposite sign, which is what I need to do when I'm using this technique. But 6 is already a multiple of 2. So if I want my goal to be to add these two together to eliminate, I'm going to need to change this bottom equation into something where negative 2y can be negative 6y. And the only way to do that is to multiply by 3. Now notice I put parentheses around the entire equation because this 3 needs to be distributed to every single term. You must keep your equation balanced, and so if you just change the y term, now your equation is no longer balanced. So I'm going to multiply each term by 3. And what happens is I end up changing this equation to where when I rewrite my first equation above my new modified, now that y term is exact opposite. That is what my goal was to make these two exact opposites of each other, so that way when I add my two equations, those terms are going to cancel. So now I end up with 18x equals 36. And if you need to use a calculator, that's fine. But in this case, x is 2. So now in my solution, again, I know the value for x, and now I have to figure out what is going to be y. All right, so now I've got to pick one of these equations to substitute. And so I'm going to go back into this original, the one at the top. No specific reason why, just feel like it. And now I need to do some work. Now when I move this 6 over, I'm going to subtract, which is going to make this a negative 12, or y equals negative 2. So in this case, my solution to the system is the ordered pair 2, negative 2. Be careful that you continue that sign, that you don't lose the negative attached to that y. So sometimes, like I said, if you have an equation where one term is already a multiple of the other, that's the one you're going to want to choose to eliminate. But sometimes, as we're going to see in our last example, there's no real right or easy way. It's just, you just got to pick one and go with it. So let's look at the 6x plus 2y equals 4 and 10x plus 7y equals negative 8. Now when I look at this, right, 7 is not a multiple of 2, and 10 is not a multiple of 6, And neither of these have opposite signs. So honestly, it really does not matter which variable you eliminate. I mean, you can just choose one and do what you need to do to make those terms the exact opposites. So you have to think of multiples. So between 6 and 10, you always look at the larger one and start looking at multiples of 10 and see which one is the smallest that you're going to need to be able to get 6 to be that same number. So for example, a multiple of 10 is also 20. There's nothing times 6 to give me 20, so I'm going to keep going. Next multiple of 10 is 30. Well, I can multiply 6 times 5 to get 30, and so that's what I'm going to choose to do. I'm going to need to multiply both of these equations. Now, if I multiply the top one by 5, 6 times 5 gives me 30. But you need to remember that one of these has to be a negative. That's the only way you can add them and eliminate. So when I multiply this by 3, I'm not going to just use the 3. I need to use a negative 3. Because I need to be able to make this negative distribute so my terms are exactly opposite. And that's important, that one of these needs to be a negative. So if in your original equation there's already a negative, you don't need to do that because the sign is already there. But if there is no negative, you're going to have to include that in the value that you are using to change your equations. So I'm going to move over here to the right and show my multiplication. I get 30x plus 10y equals 20. And here I'm going to get a negative 30x minus 21y equals a positive 24. So just be careful, your signs, that the sign is correct on each term before you eliminate. And again, now that I have multiplied everything by a negative 3 or 5, depending on the equation, now I can eliminate. So these two terms cancel out. Now I'm left with a negative 11y equals 44, or y equals negative 4. Now again, pick an equation. Don't really matter which one. So I like the first one. Again, you make your choice. As long as you can do the order of operations correctly, you'll get to the correct answer. And so again, I can move the 8 over by just adding and then divide. So not a whole lot of steps to show. Just show your substitution, and then a lot of the rest you can do the individual steps mentally. And that's my solution.